customers received duplicate charges for the same order. The 2PC coordinator crashed after sending prepare to the payment service, but before sending commit. When it restarted, it replayed its log and sent commit again, but the payment service treated the second commit as a new transaction because the coordinator's transaction ID was regenerated. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover distributed transactions and 2PC. Welcome to this deep dive into distributed transactions and the two-phase commit protocol. By the end, you'll understand how 2PC works, where it fails, and how to debug it in production. A distributed transaction coordinates multiple systems to commit or roll back as one atomic unit. Two-phase commit, or 2PC, ensures all participants agree on the outcome, preventing partial updates. ACID transactions work inside a single database, but across databases, there's no shared lock manager. Without coordination, you get partial failures, inventory deducted but payment not charged. Here's a naive approach. Deduct inventory, then charge payment. If the second step fails, you need a compensating transaction. But what if that also fails? You're left inconsistent. 2PC has two phases, prepare and commit. The coordinator sends a prepare request. Each participant writes to a durable log and replies yes or no. If all say yes, the coordinator sends commit. Participants must hold locks until they receive the final decision. Here's a minimal 2PC implementation in Go. The coordinator loops through participants, first preparing each, then committing. It logs each step for recovery. In production, keep the log in a durable store like etcetera. After a participant votes yes, it must hold locks until it receives commit or abort. If the coordinator crashes, participants are stuck. They can't release locks. This can freeze your system. In PostgreSQL, you can query PG prepared ZAX to find stuck transactions. Use rollback prepared to abort them. Also set idle in transaction session timeout to automatically abort idle ones, but ensure it's longer than your coordinator's recovery time. 2PC has three main failure modes: coordinator crash after prepare, participant crash after voting yes, and network partition during commit. Each requires a recovery procedure. Here's a recovery routine that scans the coordinator log for in-doubt transactions, queries each participant, and resolves based on their status. This automates the manual recovery process. 2PC adds at least 2 round trips per participant. With 3 participants across data centers, that's 6 network round trips plus disk I/O latency adds up fast. You can optimize 2PC with presumed abort, read-only optimization, and batching. But honestly, if you need high throughput, don't use 2PC, use Sagas. For most microservices, a Saga is a better fit. Each step commits locally, and compensation actions undo failures. No global locks, no blocking. Here's a Saga orchestration for order placement. Each step is a local transaction. If a step fails, the coordinator runs compensating actions. Ensure compensations are idempotent to avoid double effects. This is the same issue we highlighted at the start. Here's exactly why that happened. The coordinator crashed after sending prepare to the payment service, but before sending commit. The payment service had reserved the funds. When the coordinator restarted, it replayed its log and sent commit again. But the payment service treated the second commit as a new transaction because the coordinator's transaction ID was regenerated. The fix was to make coordinator transaction IDs idempotent, include a unique order ID in the transaction context. The payment service now checks for duplicate transaction IDs before processing. Also added a commit if prepared flag that prevents double committing. If the coordinator regenerates transaction IDs on recovery, participants may treat the commit as a new transaction. Always use the original transaction ID to ensure idempotency. If the timeout is shorter than the coordinator's recovery time, you'll abort transactions that should have committed. Set it to at least 2x the expected recovery time. Cross-region latency can make a single 2PC transaction take over a second. Keep participants in the same region or use Sagas. The article uses PG prepared ZAX and commit prepared / rollback prepared. These are available in PostgreSQL 8.1 Plus, but require max prepared transactions to be set 0 in PostgreSQL. Conf. The default is 0, so the feature is disabled out of the box. Without this setting, prepare transaction will fail with an error. The article mentions idempotency, but doesn't show how to implement it in a participant. Here's a pattern where the participant checks if a transaction ID has already been committed before applying the commit, preventing double application after coordinator recovery. The article's coordinator writes its log to an in-memory slice, clog. In production, this log must be written to durable storage, e.g., a database or a replicated log like etc., before sending prepare requests. If the coordinator crashes before the log is persisted, it may lose track of prepared transactions, leading to heuristic outcomes. Here's a debugging script that queries all participants for a given transaction ID and lets you commit or abort. Automate this to resolve stuck transactions quickly. Let's run through some common interview questions. How does 2PC handle a coordinator crash after all participants have voted yes but before commit? Participants are in doubt. Coordinator reads log on restart and sends commit. If log lost, manual resolution needed. When would you choose 2PC over Saga? Use 2PC for strong consistency and low throughput. Use Saga for eventual consistency and high throughput. What is the blocking problem? Participants hold locks after voting yes. If coordinator crashes, they are stuck. Mitigate with timeouts and fast recovery. And a few frequently asked questions. What is a distributed transaction? A transaction that coordinates multiple databases or services to commit or roll back as one unit. What's the difference between 2PC and Saga? 2PC provides strong atomicity but blocks. Saga provides eventual consistency with no blocking. How do I resolve a stuck prepared transaction in PostgreSQL? Query PG prepared ZAX, then commit prepared or rollback prepared. To recap, 2PC ensures atomicity across distributed systems, but comes with blocking and latency costs. Use it sparingly, make transactions idempotent, and monitor your prepared transactions to catch stuck coordinators early. Ready to go deeper? Up next, distributed locking, then consistency models, then PACELC theorem. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.